good now. So we are going to be looking at y is equal to sine x first, and we're going to prove that using these compound angles. Now, this resource was from the NZQA website. Where else would you go but your old curriculum stager? But let's get straight into it. So we know that y primed is equal to this thing that as h approaches 0, f of x plus h take away f of x all over h. Now in theorem you'd think, well, you've got h as 0, so it's kind of confusing. Oh, I actually hear myself on the stream. So basically we'll evaluate h is approaching 0 later on. So let's go ahead and put the things we need into our function. So f of x plus h is another another way of saying sine x plus h take away sine x over h. Okay? And we still need to put that limit. Now, I could be lazy and go, call it a, but can't be bothered even doing that. So sine a plus b, we can expand to this thing. So let's do that. And what we'll see is we can split up a whole bunch of stuff. So sine a is going to be sine x multiplied by cosine h. And we're going to be dealing with a positive indices, so plus and cosine x sine h. And I kind of remember what we have to get to. We have to get to cosine x as our derivative. And there is a principle that we can use that I don't fully understand yet because, you know, I haven't gone through uni courses, but, you know, I look ahead a lot because I enjoy the mathematics and content of it. Like, seriously, it's so awesome that you can manipulate stuff such as these functions just with these other different tools. It's really cool to me. So now we can take sine x out and go cosine h, take away 1, because sine x multiplied by -1 is the sine x. And now we can go plus cosine x multiplied by sine h. Alright? And that's still all over h. And expanding that, we should get that back. That looks about right. Yep. I think if I just get my calculator correctly, cosine 0 is 1. That's going to cancel. So sine x is going to cancel. And hence, we can split the limits. So the limit approaching h approaching 0 for this first thing is going to be 0 over 0, which is 0, or undefined if you really want to get that thing going. Cosine x, oh wait, there's no positive in the function, multiplied by sine h over h as the limit of h approaches 0. So here we can split the multiplications and the limit, and we can go cosine x multiplied by the limit of h approaching 0, because we don't have to evaluate the h approaching 0 on this particular thing, sine h over h. And here, what we can apply, I still can't say L'Hobbes rule. That is really butchering that. That is not it. That's not what's called. But basically, we can differentiate the top and the bottom separately and act like we're basically differentiating the two different things, which gives us the limit of h approaching 0 being cosine h. Okay? And cosine of 0 is 1. So we get cosine of x multiplied by 1, which is equal to cosine x as required. Brilliant proof. QED. Quite easily done. And that is our problem done for today. I love cookies.